All right, we are live. So, this is Cody from Landers Networking. I'm going to be going over some networking models and a couple of terminology in towards networking in general. These videos are kind of targeting towards newer people, newer to the field, so bear with me a little bit on that. But other than that, let's go ahead and jump straight into it. Essentially, if you're not new to networking, these networking models that you see in front of you here are not anything new. You have the TCP IP model and the OSI model. TCP IP model is the one that's more traditionally known. It has 4 layers. To explain networking models a little bit more, they're kind of how network engineers and technicians and IT people can divide up or segment up networking into a more understandable way of dealing with logical processes and stuff like that. So in this situation, you have the application layer, transport layer, internet layer, and network access layer. The application layer is the layer of which that you use to be able to have a buffer between like the developers and how they encode or how they program data, and what applications they're going to be using to be able to make those programs function. Here we have the transport layer, which deals with a lot of firewall functionality. Also deals with basically how the data gets there, using like UDP and TCP to be able to guarantee that the data gets there. The internet layer here is one that uses internet protocol. This is where you use IPs. Anytime you're dealing with IP addresses, this is the layer of which that you are dealing with. And a network access layer is kind of like what it sounds like. It's basically the physical portion of the network along with a couple of other functionalities to be able to, like for example, rate limit, or also to be able to segment the data into local area networks, that sort of thing. This is just the old TCP IP model. The newer model, okay, is the OSI model. It segmented the networking model a little bit more, that way it's a little bit more digestible. However, a lot of it is over segmentation here. So we have, you can see that the application layer was divided up into application, presentation, and session. The presentation and session specifically may get used with a little bit of network engineers. I know like voice and video engineers will use these to be able to, in certain situations, like for example, sessions will be used to establish sessions with voice traffic and such. But primarily, they don't get delved into too much. The network engineers tend to be more involved with transport, network, data link, and physical. You can see that they changed layer 3. They didn't change it. This is 2 separate entities that are creating a networking model. They've named their IP layer as network. And the most important part here is that they segmented off 2 different portions for the network access layer as the data link layer and the physical layer. So the data link layer tends to be the layer 2 protocols. Basically, when we all hear IT people refer to layer 1, layer 2, and layer 3, layer 4, they tend to be speaking in the OSI model specifically. The data link layer, for example, deals with VLANs, okay, virtual local area networks, along with other protocols that are on specifically layer 2, while layer 1 deals with more of the physical transmission of those ones and zeros. So physical layer examples of this would be like an Ethernet cable, would be like Wi-Fi, would be coax cable, would be fiber, those types of situations. While the data link layer tends to be the logical portion of closest to the physical layer. So it deals with like how much data ones and zeros can come through, and whether or not we want certain types of traffic. this is the layer closest to the physical layer. This is why the TCP IP model kind of grouped them together, because they considered it almost the same thing, but not quite. And that's practicality and utility wise. OSI model definitely takes the cake. But then it goes to network layer, just IPs, and everything is relatively the same. Now, the newer model, okay, the new TCP IP realized the utility of the OSI model specifically and wanted to take a look at, wanted to redefine what they had. So as you can see here, they took layer 1 and layer 2 from the OSI model, changed it into a physical layer and the data link layer, which is good, because in IT we always use layer 1 and layer 2 and pretty much always differentiate the two. And then they changed the name from internet to network, which is not a big change, but that's okay. Transport layer stayed the same here, but the TCP IP kept the application layer to encompass both the presentation and session layer. And the reason why that is okay is because network engineers tend not to, like I said, venture off into the application layer too often. It's just not something that they did. The next thing here is that you're gonna have the protocol data units here. So give me a second here. All right, so PDUs are basically the terminology we use to describe the particular type of data at a particular layer. So in this particular situation, let's go over what encapsulation is. To encapsulate something is to surround something with a particular type of data to be able to know where something goes. You can think of it like an envelope, right? You put the letter in the envelope. This is an overused example here, but you put the letter in the envelope, and then you put, the return address and the send to address on it. And so this is how you encapsulated the envelope, okay? You can think of data the same way. What happens is the payload is the data that the developers are actually trying to send. They put the layer 5 header on it. We don't have a PDU specifically for this layer, but they put the layer 5 header on it, and this is speaking in new TCP IP terminology. So they put the layer 5 header on it, and then the next thing is that we're gonna put the layer 4 header on it to be able to have the transport layer. This is gonna identify TCP or UDP traffic, and we call that a segment. So these are segments, this particular type, and that's specifically the PDU of this this layer of data, basically. So when somebody's saying the segment didn't make it through, or the segments didn't establish, or something to that effect, what they're really saying is that this particular layer of the data was not working properly. When somebody says they're experiencing packet loss, for example, this means that primarily you're thinking of a layer 3 network being able to send, basically sending a data from where you are at to an IP address, and you're receiving packet loss. Okay, this is a layer 3 conceptualization, and that's why packets is on layer 3. So dealing with IP addresses. And then you encapsulate yet again into frames, which are just layer 2. These tend to deal with the physical MAC address. The physical address, it's like a serial number on the network interface card on the equipment. And these frames are what is sent basically between devices. You can think of it as like the packets are like, hey, I have like my IP address and I'm trying to send to the IP address of that server way over there. But frames are like, hey, I'm trying to send data from my computer to the computer across the room. So you can think of it as a more shorter span of being able to deliver those frames. But yeah, the packets for layer 3, frames for layer 2. Now the PDU, which it's kind of debatable whether or not it's considered PDU, but this is where always the segment gets defined, or excuse me, this is where this is always being defined, is in the PDUs, is bits. So bits is just the ones and zeros. Okay, a wire doesn't know like a Ethernet cable doesn't know the layer 2 and layer 3 and layer 4 inherently. It just knows to send data, okay? And because of that, it's just referred to as bits, all right, as ones and zeros. You can see here, that's why this entire frame here is now just ones and zeros, because it doesn't know any different. It's just sending data, okay? So there's no layer headers here, and the PDU for this is referred to as bits because we're transmitting the bits across a physical medium. But yeah, that's pretty much the 4 PDUs of this and how you describe this. So there's sometimes network engineers can get a little bit snarky and be like, that you're not getting packet loss, you're getting frame loss. And that's like a little bit over the top. Nobody cares that much about it. But when somebody is speaking in a particular type of terminology and they say, I'm receiving packet loss, you kind of already know where to set your mind and say, okay, we're dealing with a layer 3 issue here. So that's pretty much it. I wanted to go over the differences. I wanted to go over basically the change between the models now. I think that the new TCP IP model is going to be perfect for what it needs to be because it incorporates exactly what we needed from the OSI model while simplifying the application layer, which is not something that people tend to use anyways. I think that this particular type of model is going to work out. Now I'm going to continue doing videos like this, so go ahead and leave me a comment below and tell me how I did. And we're going to just keep going and do more network terminology. Hope to see you in the next one.